Welcome back, everybody, and hello, Roberto. How are you today?
Good. How are you? Can you hear me well?
Yes, absolutely. Very good. Very good. So, where have you flown in from?
Okay. So I'm from Virginia, from the U.S.
Yeah. And you're still in Virginia from the US.
Yeah, Virginia, from the U.S., Virginia, and kind of early, I guess.
Yeah.
For me, a little bit. I usually work late and wake up late, but this is fun.
Typical InfoSec hacker, right?
Yeah. But no, thank you for the opportunity, everybody, and looking forward to talking about these projects as well. So
absolutely. So please start to bring up your slides. Your talk is on comprehensive cross-domain enterprise threat exposure. No, that was the last one. Sharing open data sets with the world to develop detections from home. So there you go, and you are up and running. So Roberto, thank you, and take it away, please.
All right. Well, thank you very much. Well, first of all, thank you everybody for joining my talk, and this is gonna be a couple of things talking about some projects, but in general, focusing only on one, which is something that has been helping me a lot to start doing research. And this, first banner is pretty much a community behind all these projects, and it's something that I'm going to talk about also in a little bit. And the talk today, of course, welcome to Mordor. I'm a big fan of the Lord of the Rings, so that's why the name of the project. And this is more related to how can we start sharing data sets with the community after emulating or simulating an adversary. And once again, my name is Roberto Rodriguez. I work for Microsoft, for the Microsoft Threat Intelligence Center team, the Mystic R&D team. And I'm also the founder of the OTR community. And also, I love open source. So there's a lot of projects that I have developed in the past couple of years. So if you're interested on some of them have Twitter handles. So you can just follow them, and then we can start also having a conversation about those. And my Twitter handle is CyberWarDoc, just in case if you want to continue the conversation in Twitter as well. And the agenda for today is going to be talking about kind of the basic process of research and how that translates into the need for data. And then I start talking about a little bit of these things that you can do in order to generate the data. And then at the same time, go over how this project started and what are the different things that you can do with it, all the way to the couple of things that you can do in the future as well with some of the things that are in the roadmap. So let's just start with the first part, which is what triggers the detection research. And this happens a lot, especially from home, right? For those that are doing research from home, besides what you do at work, right? Because that's a little different sometimes, because when you do research, sometimes your organization will define some of that research, right? The specific research goal can be related to a specific, for example, policy that just came out for your organization, or it could be a specific environment that you need to focus on the most. But in reality, for a lot of people, it's pretty much research starts from Twitter, right? There's a lot of different things going on now. In the past 2 months, there's been all the way from awesome lateral movement techniques being released by the MDSec Labs, team, all the way to start also dropping a few, POCs, like proof of concepts, for a couple of CVEs that also start popping out there. So this is pretty much where I get a lot of my inspiration as well. So if I were you, you're not in Twitter yet, I would highly recommend to join the community and to start also trying to, take all this research and start understanding it, and so that you can apply your detection approach as well. So what can we do, right? First, we consume that open intelligence, and the first thing we do is to start trying to Google if there is any detections out there. Has anybody even written a, just an article or probably shared the detection rule? And then at the end, of course, you start thinking, okay, now if there is not much out there, can I actually do it myself? Can I start replicating this? And there's when you start, Googling also if there is a, POC available. And of course, the next question is where I'm going to deploy this. I'm going to do it on my local computer. Do I have to set up my own lab? Do I have to probably spawn more than one computer? all those questions are valid, right? All those questions are valid. And if you're realizing a little bit, a lot of those questions are more related towards before you even start executing your research. And you're not even getting to the detection piece yet. And unconsciously, right? And indirectly, you start creating this methodology on your own. So I started doing the same. And I started putting together a couple of main steps, starting, for example, from my research goal, right? This specific tweet that I liked and it was very interesting, and then there are no detections about. And I go through this, whole cycle. Now, of course, a lot of things do not just go clockwise all the time, right? There's a couple of things that you will have to go back and start doing some of the feedback loop and trying to improve a couple of steps. But behind this, right, because this is very high level, and of course this is only one approach. There's a lot of approaches out there, and people also choose what they like to do the most. But for me, I actually put in a couple of other steps in this specific basic methodology. I was working with my brother on this because we had a couple of ideas into what should we do next, what can we add as a step that would allow us to improve the next step, and then once again do this feedback loop across all these different steps. But when we talk about trying to understand the adversary, besides doing a lot of the which is necessary, a lot of the static analysis or basic and advanced dynamic analysis, for example, you start getting also into the part where you need to simulate it, right? And this is the part on that side of the methodology which we're going to focus today, and that part sometimes is where a lot of people actually get stuck, especially from a detection side. Not everybody has the expertise to actually go through all this and create their own tools, their own POCs, and execute a CVE just like that, right? So that's very important to understand where all these steps actually fit in your methodologies, so you can also probably start collaborating with other people that might have the skills to help you in those aspects. So this takes us to the simulation part, which as a basic strategy, right, you need to start exploring the tradecraft. Like, you need to understand a little bit of the tradecraft, the techniques behind it, the procedures and tools probably being used out there. You need to start, creating your plan of simulation. Sometimes it could be as easy as running one command. Sometimes it could be a couple commands, could be a new script, it could be a whole emulation plan. And then you have to do this also feedback loop in order to start understanding what it is that you can do as well to enhance that environment that you're working with. It's not just enabling telemetry, but it's actually creating more context around that telemetry, and probably enabling a couple of other more configurations, or probably adding more data sources to your flow. And then, of course, once you are close to a detection or you're feeling comfortable with some of them, that needs to be documented somewhere, right? You either document it for your organization or you document it to share with the community. So that's also up to you. And something that I've been doing also a lot is actually sharing as much as I can with the community. But there's a lot of challenges. And some of the challenges that I have identified, it's a lot of time and technology constraints, for example. Once again, some of these might be very easy. Some of these simulations might take time. For example, from my experience, I'm not doing a lot of the offensive research, but I try to learn a little bit, trying to learn what it is that I need to do in order to be more proficient in that piece and start building my own tools as well. But it takes time, right? For me, sometimes it takes probably a week or two in order to get to a really good representation or a good proof of concept of a technique that was released recently, right? All the way also that goes along with expertise. And of course, you start thinking what it is that I need to collect. Once again, it's not as easy as just running something and then expecting data to come out. There needs to be a lot of different configurations around it. If you're dealing with a use case that you need to understand, what specific actions of the adversary would trigger or potentially would trigger some of those events. So just to kind of get a few examples to tell you how also some of my days go, I can go with the basic creation of a local user account all the way to, for example, trying to replicate a specific DLL hijack that was released in the community. So from a local account perspective creation, there is this project called Atomic Red Team, and they have a lot of different scripts that would allow you to simulate that specific procedure as well within a specific tool, and you'll be able to get an understanding into what these actions actually, what data actually is kind of generated for these actions, right? And that's very easy. Usually you only need one computer to do that, and you only need probably just one console, command and prompt, command prompt console. You just run these specific commands, and then you can just do this, right? But then when you start getting into this type of research where someone says, hey, I found a new lateral movement technique which involves, for example, like copying a DLL over SMB, and then also start interacting with the service control manager, and then trying to query the service, start it, stop it, and trying to go through this process, it is not that easy, right? Sounds, well, for some people might sound very easy, but for a lot of people, this is not as pretty straightforward. And just to give you an example, right? So the way how this works is that you have two computers, and the adversary or the threat actor, performs research before executing this, of course, and identifies that there is a vulnerable service that exists on any, for example, Windows 10 computer, right? So there is no need to create a new service in this case. And then it starts interacting with this other computer, through RPC, for example, and it starts, getting a handle to the SEM and trying to query the specific service that wants to, do the DLL hijack for, and then stops the service. So you can do it with a control service RPC method, and then you use the SMB create request session in order to copy that DLL that the service is going to actually look for and execute. And then at the end, you start the service, right? So this can be done through a few commands. It could be done through, for example, some scripting languages too. Or you can just do directly pure RPC through some other, command line as well. But then you start thinking, okay, now that I understand a little bit what's going on, so now I have a lot of questions, right? So what are the things that I need for each specific thing that is going on in here? This is, of course, something that you can do prior to simulating all this, because by understanding the trait graph, you can start understanding this specific model between an action of an adversary and also a specific event ID, for example. But then you start asking, what can I do from a service perspective? What audit policies can I actually use to start, monitoring my services? And here's when you start doing some research, for example, on these system access control list, SACLs, on the specific service. Or you can also create a SACL on the SEM itself, right? Then you might ask yourself, why do I need to do that? And why do I even care? And what makes you even think that you need one over the other one? Is exactly why. Because in this case, for example, the blog post that was shared by the researcher Dwight that discovered this specific lateral movement technique through DLL hijacking, was that instead of querying the service directly, he was using actually a different RPC method, which interrogates the SEM and asks about the status of all the services. So it doesn't actually touch the service directly. So if you create a rule on that specific vulnerable service, so that if anybody touches it, there is an event that happens, well, if you use a different method, that event is not going to trigger. So you need to also account through some of these also, variations of this technique. And that just happens all the time, right? There is a lot of things that you will have to consider if you want to start building a detection around one specific procedure or technique. So that was very interesting, right? There's a lot of things that are happening here. And just after telling you all this, you are still in that section of a whole research methodology. You're just kind of like trying to figure it out how this is going to play out, how I'm going to simulate it, and actually what do I need in order to simulate and also start getting the data from this environment. This happens everywhere, right? Everybody else is doing it in a community. In different countries, I've talked to people and they say, yeah, we do research. The moment something happens in Twitter, we just start getting together and start trying to figure out how to replicate it and how to get data out of it, right? And of course, some people are successful. Some teams, some communities, some organizations are successful. They can just do it right away. But the problem is that there's a lot of people that are not successful. For example, myself, there's a lot of different techniques that get shared almost every day, and I cannot replicate a lot of them. And I actually collaborate with other researchers that are great researchers out there that help me with the POCs. For example, like how can we build a specific DLL that will, for example, spawn on the thread of a process, or probably create another process and then inject code and then create a thread to execute code. So how can we start, building all of those things, right? So that's, to me, was, very interesting, because when you start thinking about why don't we just start sharing some of this data that we're generating, right? If it took me a week to figure out how to do, for example, this like lateral movement technique, why can't I just, collect the data after doing my research, of course, right? Understanding what do I need. For example, I talked about a little bit these audit rules on services, and then I can share that with somebody else, right? And then this person or whoever I'm sharing this to with in the community, they might be more proficient on the data analysis piece, right? We have to find, understand, identify our strengths, right? Where we're actually good at. And that's good, because sometimes you might think that because you're not good at let's say the simulation step, you might just get stuck in there, and you might think, I'm not doing as much and I feel uncomfortable, like this is something that I don't something I don't like, right? But in reality, you're really good at the other steps. So to me, it's like, how can we empower other people in the community that have skills as well in other parts of the methodology, just by sharing the data? And that's pretty much where the Project Mordor started. And the Project Mordor is just a repository of data sets that are shared after simulating an adversary in a specific technique or procedure, and everything is in JSON format. And the reason why I'm sharing everything in JSON is because I believe that it's a more portable, easier to use type of data or specific file that I could use. For example, with Python, I can use it with PowerShell, or I can just integrate it with other SIMs. For example, I can throw a JSON file to a data pipeline directly, and that could make it all the way to my SIM. So that was the idea a little bit. And also I started categorizing all this by the MITRE ATT&CK framework, like specific tactics and techniques and all that. And also something that also differentiates this project from other projects is the Mordor project also generates atomic samples, a specific data set for specific actions, just like the ones that I just showed you a couple minutes ago. And then also we cover large data sets. So data sets that are created after simulating a whole campaign, not just one atomic behavior, but actually multiple atomic behaviors. And I'm going to explain to you what that actually means and how it's being done. So at the end of the day, with the Mordor dataset, for example, my brother, it's over there at the bottom. His name is Jose, and his handle is Cyber Panda H, just in case if you want to follow him. And the awesome thing about this project is that this also started with us helping each other. It started by me saying, hey, I have this data set, and you're actually good at analyzing data. Because his background is more from the data analysis, data science aspect of InfoSec. So for him, it was very easy just to say, hey, can you just send me the data set? And I can start building probably some detection rules, or I can probably import that into a Jupyter notebook, and I can start analyzing the data, just exploring the events that were collected after simulating a specific technique. So that was very helpful, and that was also the inspiration to help others in the community. The Mordor dataset, if you go to that website, you're going to have pretty much on the left all the specific data sets that we have for a specific platform. And then I also have this what's it called, Attack Navigator view, where you can see just some of the things that the data sets cover. I focus a lot on a specific technique, so you will see a lot of procedures under one technique. So don't get scared if you only see 6 or 7 or let's say 10 things highlighting. There's a lot of things under those techniques as well. And kind of showing the example that I talked about a couple minutes ago about DLL hijacking. So there is the link at the bottom, and you can see pretty much how it was done. That also is part of the project. So if you contribute on a specific data set, I would love to know how you actually get to the data set so that you can just add more context to someone that is actually using it and consuming it. For me, that's very important. Having metadata about data sets beyond just event logs, it is crucial for somebody to kind of like get familiarized with what's going on and also trying to understand a little bit more of the tradecraft without executing it. And at the end, I also provide a little table of all the events that were generated in that period of time. Now, something that you might have noticed already is that you might be asking yourself, why not share only the events that are actually related to that technique? Why do you have to share a whole period of time? And to me, it's because there is a lot of rules out there that if you only give it, for example, one event, that, let's say event ID 1, and you say, look for this specific command line, for example, but that command line is also executed by other processes, and you need to have that extra noise on the top of that if you want to actually have some type of validation going on as well. It doesn't occur, of course, in every single data set where you're going to have some potential false positives, but I've seen data sets where even though I say, oh, this query is very good for this specific technique, and then I apply it to my data set and I have more than 20 or 30 events that occur. So that allows me to see what context can I add to my query in order to improve it. So having a data set with more context allows me to also have, create better queries and also enhance my queries, and also have the opportunity to join a couple of data sets at the same time. Now, some of the environments that this project comes with, and exactly what you can do with those. There is a strategy for Mordor, and there is two things that we have identified works, and I think it depends on how much time you want to spend actually creating a data set, and how quick you just want to share something with the community. So the first one is having your own local computer, or it could be a virtual machine, or it could just be one machine in the cloud. But I assume that a lot of people have their labs in their own computers with like specific programs like VirtualBox or VMware. And in that scenario, I believe that you can also get that data out of it directly. And I put together a PowerShell script, which I'm going to show you in a little bit. And with that one, you can easily point to a couple of event providers like Sysmon, like security application system, and you can just pack all that data that happened right after you execute a technique, and you can pretty much collect that data, then share it with the community as well. The other strategy is actually using a bigger environment. And when I say bigger, I don't mean hundreds of computers. I mean probably 2 or 3 computers. Some techniques require more than one computer, like, for example, lateral movement. And of course, if you're in a domain environment, you need to have also a domain controller if you want to also capture some of that data. So talking about local computers, this is pretty much what I would do. I would just download this script, and of course, you're going to have the slides later. But if you go to the GitHub OTRF, as you can see in the link at the bottom, Mordor, and you go to scripts, you will be able to see that script over there. So you download that into your local computer, you import that specific module or that specific script, and then you can first clear the VM providers that you have. So pretty much before you want to execute something simple, clear your event providers, run your or specific techniques or one command or a couple of commands. And then you can run the last step, which is going to grab all these event providers, and it's going to use PowerShell to grab that data, parse the XML out of it, and then create a JSON, create an array with a couple of JSON objects, and then it's going to merge all those event providers into one array, and then just copy that to a JSON file. I find that very easy to do and pretty straightforward. And once again, I don't want to collect only one event provider. I want to collect more than one. At least security and Sysmon is pretty good, because you can have events also that are not created in Sysmon that might be good context for your detections. The other case, and I'm going to show an example in a little bit, so don't think that that's just it, right? I'm going to show you a little bit how I actually did one. And then the other one is a couple environments as code. And here's where it starts getting not complex. Well, complex for me because I have to figure out all these different pieces together so I can just share everything to you, with you. But there's a couple of things going on. So Blacksmith is a project as well, part of the community that I'm part of, the OTR community, the Open Thread Research community. And Blacksmith only has configurations and scripts that can be reused anywhere else. For example, if I have a sysmon config and I want to create 5 to 6 environments with the same config, why would I copy the config 6 times? And if I want to update the configs, I'll have to update it in 6 different places. So Blacksmith for me is more a centralized repository for a lot of scripts, a lot of configurations, and that I can reuse them somewhere else. Simuland is another project, which what it does, it actually creates environments through templates that have a specific purpose. So think about, every time we say, for example, the emulation plan, right? I have an emulation plan for APT29, for example, but the plan usually is commands, right? It's a couple of commands, a couple of payloads that you can use. Think about Simuland as the emulation plan, but from an infrastructure perspective, like everything that you need to deploy in order to execute that specific plan. And then at the end, Mordor is pretty much just waiting for the data to be generated by environments like Simuland, and then could be shared to the Mordor project. So talking about Simuland a little bit, once again, it's just a combination of cloud templates and scripts as well that are grabbed from the Blacksmith project, and that are just pretty much being put together to make sense and to kind of like replicate a little bit what a potential APT did, right? Because a lot of the emulation plans are actually based on open thread intelligence. So we're just working with open thread intelligence. That's not mean 100% that that's what they did, but we're just working with community resources as well. So the next one, some of the environments in Simuland, for example, I talk about one which is the attack evaluations environment, and that one pretty much follows the attack evaluations program, where they actually assess a lot of EDR solutions and they share their emulation plan. So what I do is I just take that emulation plan, create the environment, and then execute it and collect data. The other one that we have is Cloud Bridge S3. So this is just a basic scenario which would allow me to cover potential techniques where S3 buckets are involved. And I have the difference with this environment and other cloud environments is that the environments that I create do have a data pipeline attached to it, which means that I'm not just attacking the environment. Usually when you see an environment out there being released by somebody to use for practicing a couple of adversary techniques, it's only to attack the environment. But there is not a concept of, okay, so I'm attacking the environment. What data is being generated, right? So this environment actually enables like CloudTrail logs, for example, and they're pushed to Logstash and then are pushed to to a Kafka server. It's just a server that allows me to centralize my data, and then from there I can just take it out. And then we have also the Shire, and the Shire is just a Windows environment, which is trying to replicate, I would say, like a very, very small environment. But the good thing about the Shire is that it's very modular. So you can actually deploy only one computer, one domain controller, and then a couple of things more that would allow you to get the data out and then push it out, for example. And if we want to talk about a little bit this environment, once again, all this is deployed by the Azure Resource Manager services. This just allows me to share a template with the community. The community can just click on it, and that just gets sent to Azure and then gets deployed in Azure, and then you can use it directly. I was thinking on doing some Terraform, but to be honest, I'm very busy with a lot of things going on too, with a lot of different projects, that I'd rather just focus on one thing and then try to understand also the ins and outs of like new APIs and things that are coming out. Like almost every month there is like a new feature. So I'd rather just not wait for other features to be enabled and just start using this thing directly. So the data collection from the Shire is pretty straightforward, and there's just a couple of things that of course, might be a little different from what you probably would like to do. But in this case, we're using Windows event forwarding from every single computer in this environment and then push it to a Windows event collector. Now, all the policies, all the Windows event, the web configs, for example, all those configs are in Blacksmith. So you can just grab them from there, and then you'll be able to see exactly what are the specific things that we're collecting. All the data gets sent to the Windows event collector, and then we have nxlog, community edition, sending data to Logstash, and then Logstash automatically sends it to something called an Azure event hub. And then from there, I can just pull it out directly and then just, push it to my repository. So as you can see, there is two different scenarios, right? A local scenario that you can use, and then you can also use this other infrastructure. So it would depend also on how complex you want your scenario to be. And I assume that a lot of people will start with a basic PowerShell script on their own VMs. But just to let you know, there is also environments available that you can use. So once again, that's just the flow. That's pretty much how things will go if I try to create something in Simulant. And as I mentioned before, all the audit policies, all the, for example, like PowerShell logging, how do I enable all that? It's in Blacksmith, so you understand what data is actually being created and how is it being created. So if I were you, and if you want to contribute something from your own VM, I would definitely take a look at these configurations and see what we are considering good configurations to enable telemetry, right? Because you don't just want to start a fresh Windows 10 computer and then say, run my attack and then expect something to happen, right? So there will be some configs that will allow you to have some more telemetry. Then we get to the SACL, right? So this is also something that gets applied into the data sets of Mordor. So I have a project with a lot of different SACLs, and this gets applied to every single computer on the Mordor environments. So once again, if I were you and I am documenting my own VM, I would definitely take a look at those scripts as well. That one in particular pretty much are rules that allows you to track when somebody queries, for example, queries those values, like those registry keys. And for those that are not familiar with those keys, those are the keys that would allow you to actually calculate the key, a sys key, to access the, for example, SAM database, right? The SAM file. So you need to have that sys key in order to access that, and also decrypt the contents of that and try to get information like hashes. So those registry keys, for example, are not being audited by default, right? But if you audit those, it might be an interesting exercise for you as well to know what processes are constantly querying those things. So as you can see, there is research behind the telemetry decisions, and that's something that you could definitely also use on your own VM as well. And as I mentioned before, there is also SACLs on services, and this is very interesting because if you're not doing this in your environment, I would highly recommend for you to do it. For example, like in the DLL hijack example, the service that was vulnerable and the service that Dwight was talking about was the IKEEXT. So what I did is I just enabled this audit policy, and as you can see, some of the commands in there. I just grabbed that service and I apply I just added this entry on the specific access control list. And I also do it for SC Manager, once again, because I also want to track, who is doing what. Now you might be asking yourself, okay, but I don't understand what these things mean, right? And believe me, it took me a while also to figure it out, like how I'm going to be playing with these settings. So I also give some of these strings on the configurations for Mordor. And as you can see, like there is a couple things that are related to services. So I want to track when a service starts, when a service stops, and its query and all the stuff. The interesting thing about this SACL for a service, or for example for SEM, is that at the bottom you can see that there is this WD and NU stuff. if you track the NU, like if you set up the specific accounts that you want to track, and you set it to NU, that's going to track all these accounts that are coming from over the network. So if somebody is querying your SE manager, for example, over the network, remotely from another computer, potential lateral movement exploration probably. That's a very interesting use case, because it would be nice to know who is querying or who is touching the SE manager overall remotely, not locally, because that happens a lot locally, right? But if you set it to NU, you'll be able to capture that telemetry. So that's also another data point that is very interesting, and actually a lot of organizations have talked about it, how they can leverage SE manager telemetry, for example. And that's just one example that gets applied to also the Mordor environments, the ones that are deployed as code. And once again, the configurations are there, so you can just take a look at them. And those are what they look like. And pretty much we haven't sent as much yet. We just kind of like collected the data, configure it, but then we have to send the data out. And of course, once again, the destination is an Azure Event Hub. And you can see all the configurations also in the environment. So of course, if we talk about every single configuration, we might go through the whole presentation. But at the end, the idea, like this image is very interesting, because you're pretty much seeing the amount of data that can be flowing in real time and data that you can start collecting. And at the end of the day, I use this tool called Kafka Cat in order to collect that data. And that tool, pretty much what it does, it just connects to the hub, grabs the data, and then pushes it to a JSON file. Nothing complex. Like if you actually go and read about it, it's pretty straightforward, and it's just a client that you can use to gather data. So one quick example is this one. There you go. Oh, let me just click in here. Sorry, I was clicking on the on the on the other screen. So as you can see on the left, we have already a compromised computer, but on the right, we can run the specific command, and you can see there is just data flowing, and this is just like real time. Like this is data being collected from the pipeline, and it's just data that I can start pushing somewhere. Once again, if you do it locally, it's pretty straightforward too. But if you want to also capture it in a pipeline mode, that's the way how I would do it for sure. Oh. So let me just move to this here. So the other one was just another example. It's pretty much the same, but it's just pushing it to a file, and we're just making sure that I'm, looking at the time as well. But in this one, for example, a lot of people were asking me, what about network data? What about pickups? And I actually use network shell on every single computer that I want to collect data from as well. This scenario is when you want to do it, for example, locally on your own VM. If you want to contribute pickups to Mordor, this is something that you can use in order to get that data, that pickup actually the moment you do something that will, flow through your, NIC, for example. If you do a lateral movement technique, it will be nice to capture the pickup, the network traffic in a pickup. For example, so you can use that command if you want to contribute a pickup, for the Mordor project. So at the end of the day, you have to use another tool, which is called the ETL2 pickup ng, and then that's going to point to the ETL file that gets created after using network shell, and then that's going to give you a pickup that you can just start seeing in Wireshark, or that you can contribute directly to the Mordor project. So if I were you and you're trying to contribute to a project as well, and you have a VM and it's easy for you to execute something that might make a network connection, and you want to share that data, just run those two commands, and then you will be able to share that data. There's another option too through Azure, and this is something that you can just also read about more in the link below. But that's just something called Network Watcher Agent. The difference with the other things that you might have on your endpoint is that this actually is just an extension that gets installed on your Azure VMs, and you can just collect the data as if it was just another device in the middle between your computer and the rest of the network. So you can just capture data through those commands. And once again, once you have the slides, and you can also read at the bottom, there is more information about it, because I wrote a whole blog post about that specific thing. And at the end, what it does is just pushes that PCAP to your network watcher, for example, in here on the top, you can see that it's running. And then at the bottom, you're just gonna see it in a Azure container, where you can easily download it and then just use it. The advantage of this is that if you have an environment with like 20 computers, let's say, or 10 computers, you can just run this command and point that to several computers, and then you will be able to get all the PCAP from all those computers. And that, of course, is if you are not using any other things to capture network data. So this is just an option, another thing that I use as well. All right, so that's pretty much how the Mordor project it's maintained, how the Mordor project is actually being shared from an infrastructure perspective, and also from an organization perspective, like how the data sets are organized and all this stuff. But what can you do with it? There's a lot of things that you can do. You can go all the way from trainings, from job interviews, for example. You can use that to actually interview somebody, because somebody could say, I'm very familiar, for example, with lateral movement techniques. Great. There is like 10 to 20 different techniques where we have data, and we can just push that data to a location where you can just tell me what it is that you could do with it. And at the end, of course, you can validate a couple of queries, and you can contribute to other projects. And that's pretty much also what I wanted to share in this presentation. So what we're doing now is we're just pretty much skipping a lot of those initial steps in the whole methodology and running directly to the analysis and sharing of the data. And that's also the goal. How can I just share data so somebody else can use it and also benefit, learn? And at the same time, if there is not a rule created, for example, in the Sigma project, you can use it to create a rule, and you can use it also to validate the rule. So, for example, going back to this specific example, like I ran through this, and now I have a data set in the Mordor project. So now I can just grab this data set, and I can start running some queries on the top of that. I use different tools to do that. One of them is Jupyter Notebooks, and there is a lot of information about it also in Google, like how to deploy and all this stuff. I also have a specific website that you can go. I can just do it since I can see that you guys can see my my browser tabs. But if you go to InfoSec Jupyter Book, for example, like I also put together that project so you can get familiarized with it. Okay. So, for example, in this rule, I was able to query, for example, any indicators that the SE manager was being queried, for example. And in this case, of course, as I said before, you can track if there is a network log on. But if you're just tracking any interactions with your SE manager, for example, you can add context from another event like 4624 from Windows Security Audit, and you can do log on type 3. You can join those for example, 3 events, and then you'll be able to get to actually users that are interacting, querying the SE manager over the network, for example. So that's something that could be validated right away with the Mordor data set, and you don't have to go through the whole process just to emulate it or simulate it again. And of course, for those that are curious to know what those specific access masks or just access rights mean, you can see that in this data set, we actually capture the behavior that we were talking about before just by monitoring the SE manager, right? Connecting to the SEM, querying it, starting the service, stopping the service. And that's pretty much what we had in this whole methodology of this specific technique. So that was pretty cool, right? Because we can just get the data and start validating analytics. This is another example that I also collaborated with the team from NDSec Labs. And in this one, they were using, for example, code execution via DCOM, Excel, Register, XLL. And this was a very interesting one because you can actually see that interaction. For example, you can see like RPC being used, and then you can see the request to that specific class. And then you can see at the bottom that the value also is calculator or calc.xll, for example. So that was also something that I started playing with, and I was able to create these rules as well, where it tells me that a process, for example, which is Excel. If Excel is launched with the automation, arguments, and then the parent, it's also, running DCOM launch as part of their arguments, that could be an indicator of Excel being used automatically, and it could be an indicator also that it's being done over the network. So once again, this data is available, so we can just download it and start creating rules. And this was one of the contributions, very basic contribution for the Sigma rule project, which I grabbed this telemetry. I went through the whole blog post, and I was able to share that with the community as well. This was another one, WMI, also DLL hijacks using that specific DLL, which is called WBEM-COM. And it has a similar behavior as the other one, but this one has a little twist, because if we execute WMI and this DLL is just a plain DLL waiting to be executed, that will be hard to actually mimic what the WMI execution would do. So you have to add some also like proxy some of those exports to that specific DLL. So all that is being done as well through Mordor. We have another rule, and we have
no time.
Oh, sorry. Oh, 42 minutes. Yeah.
That's when the next talk starts.
Oh, okay. Sorry about that. I thought it was.
You were scheduled to finish 8 minutes ago, but we enjoy the enthusiasm. We enjoy the. So if you want to bring up one last slide.
That was pretty much like the end. So the end will be how to contribute, and you can just go to that link at the bottom. The slides are going to be shared. But at the end, the only thing that it's left is just you can join the Discord server, and we can talk more about specific Mordor data sets and just contribute with the community. So that was it. That was just the last thing.
And please hang on and jump into our Slack channel as well.
Okay,
so that people can ask you questions there too. I do have one question for you, very briefly, before we move on. What do you think of the Amazon remake of Lord of the Rings?
Oh, well, I haven't watched it, but haven't seen what's going on with that thing. But I'm a big fan, so I will give my feedback when I see what's going on there. But I haven't seen it.
Okay. Replied like a true consultant. So. Right. Roberto, thank you very much indeed. Absolutely fascinating. Very, very deep knowledge there. Folks, everybody go to the website there and contribute and take part. Use the tool. Unfortunately, when it comes to the end of the talk, you shall not pass another 2 minutes. So, Roberto, thank you so much, and you get my virtual round of applause and whoop whoop for a fantastic talk. Thank you, sir.
All right, appreciate it. Take care. Bye, everybody.
Bye. Bye.